Hi everyone, good morning, good evening, good afternoon, wherever you are. I think the event is running kind of 24 hours a day. So I'm here in Germany, Central European time, and I'm glad to present you my session. Let me share my screen and then let's start. Okay, here we go. So welcome to my session, Graph Native Agents, Neo4j plus Microsoft framework in action. Actually, I call it my dream stack. I'm already a long time a big fan of Neo4j graph databases, and especially of Cypher. I think it's a really, really cool language. And one thing that I really love, what has come now together, before it was always complicated to extract knowledge graphs actually to build them, but with large language model now it's become super easy to extract it because they can extract natural language into knowledge graphs. And so I think this is a big thing for GraphRAG and graph databases. And yeah, I'm happy today to share you my experiences with using that together with Microsoft tools like the brand new Microsoft Agent Framework, and also use Azure AI Foundry models. But yeah, let's start first with a short introduction about me. So this is my personal graph. Yeah, but I think it might look even better if you watch it as a bloom and actually execute that graph. So I'm Christian Glessner. I am the founder of HoloLux, kind of my main company. I also have another company. It's called Rise Technologies, where we do mixed reality solutions for real estate. I also work at AdWork as chief AI babysitter and do a lot of customer projects here in Europe with larger customers together with Microsoft in the area of agents and graph. I'm also now for 17 years a Microsoft MVP. You might do not know that program. I call it the Oscar for Microsoft. You have to win that or get awarded once a year for sessions you do, open source project, any kind of community engagement. And the advantage of this program is you work very, very close with Microsoft. So you get most information as NDA, you give the product teams feedback. And yeah, so I'm happy also to be already a contributor to the agent framework, already in the stage of private review and actually helping building that things. I also started super recently a new blog, which barely has content right now. I love agents. And sometimes people ask me if I work a lot. Actually, no, actually I work not at all, because I think I have everyday holiday, because actually I do what I love. So I hope you're also in that position. And now I want to share you a little bit of the things that I love. Coming to the agenda, what we will do today. So first, I think, maybe you didn't hear about agent framework and Microsoft, very famous, the building things here, renaming things. So we will clarify a little bit, where is agent framework, why Microsoft did a new framework like agent framework. And then we learn a little bit the basics and the things that I think makes it a good framework. And then we jump more into in a demo with a contract database, where we extract contract data, store them in a graph. In the last step, we use an agent to query them via a GraphRAG. So agent framework. Agent framework. So Microsoft had already some frameworks. You might know Microsoft had already, or still has a framework called AutoGen. It was driven by a research department of Microsoft, primarily built with Python. Then they started to do a C# implementation, and it was quite advanced in the area of multi-agent, latest kind of multi-agent workflows. On the other side, another team at Microsoft started to build another framework. It's called Semantic Kernel. It started with C#, and it also made a Python implementation of this. and it was mostly focused about a concept, the architectural concept about kernel, and especially made more for enterprise readiness for customers. So then Microsoft did a decision to say, okay, maybe we have a little too many frameworks that develop in parallel. And so there, in the future, there will only be one framework, and that's the agent framework. And it's not that they just put all their innovation there. It's actually the team, the research team from AutoGen and the semantic kernel team. They are now one team, and they both work on agent framework, which is kind of developed in parallel with Python and C#. It's always a little bit, sometimes it's here Python a little more far than in the other side a little C#, but it develops exactly in parallel. Also, maybe one thing you have to know for now, it is still in public preview, so some things might be a little bit bumpy still in the agent framework, but it works already quite well. So what are highlights of the agent framework? So it is the unified successor to semantic kernel and AutoGen, and it brings the cool research stuff, multi-agent latest stuff together with enterprise readiness from the semantic kernel. So they, in the advanced scenarios, in a little bit of the engine that drives this, you have a graph-based agent workflow engine behind, which is able to orchestrate agent steps, but also, let's call it classic services, classic things, and mix them together in larger enterprise processes. For sure, it has a built-in state and context management, which can use also different memory providers, different stores for conversation. Tools in MCP is a first-class citizen in that new framework. And Microsoft also took a lot of consideration to make it very good monitorable what things are actually going on, so that especially if you have a larger multi-agent process flow, it is sometimes hard to follow up what the agent's doing. And this because there's a high dynamic. And so Microsoft also did a lot of effort to make monitoring really good with OpenTelemetry integration. So, and you can run the agents, also an important topic, you can just run them easily locally, but you also can run them in the cloud or in container or in Azure AI Foundry, so that they also scale and persist for your enterprise cases. So there are already some strong competitors in the area. LangChain, I think, is the most famous one. Also, Neo4j has a lot of integration for it. And it is, I think it was established around 2023, and it has a huge ecosystem. You find really most of the plugins and things for LangChain. It's definitely a good framework. And on the other side, you have brand new the agent framework. What I like a little bit about this, and this was also the decision why Microsoft actually decided to start something completely from scratch, is because you see in semantic kernel, you had a lot of stuff, like that kernel principle, and also in AutoGen, you had some older stuff. And this area of LLMs and that language models, they developed so fast that you had so much lesson learned, and then you had always to check how you bring your infrastructure up to this. And so Microsoft built it from scratch. So it's a completely new, fresh thing which has no old garbage in it, and that I think is quite cool. If you look on the code, you will see it's quite clean, and actually customer love it a lot. Because it's from Microsoft. So most of my customers work here in Europe with Microsoft Azure, and they're very happy if Microsoft integrate that tightly into the Azure AI Foundry ecosystem. So, but I would say enough talk. Let's start our first agent here. So it's quite easy to write an agent. I think this is in most of frameworks super easy. One special thing, I use here Azure CLI credentials, but better would be Azure default credentials. So you can use here either API tokens, or you can use OAuth client credential flow. So you're also flexible what the authentication is doing here. And in this case, I use an Azure OpenAI response client. You could also use an OpenAI chat client. You can use different model providers here. Let's run it. So my model is deployed, like you see already, at Azure AI Foundry. Yeah, so it seems to be a complicated request. Yeah, so okay, it's so it's done, it's executed. Let's say nothing too special here. One thing that you will see later is that there's an abstraction, especially here, that the abstraction here is very well done and you can easily change the provider. Let's go one further and integrate a simple tool. Did you see how this looks like? So in this agent, it's kind of pretty much same agent, but we have a tool here. So Array, you can for sure bring more tools in. You can also as easily as tools bring in a local or remote MCPs. We have the same agent, and here a tool is nothing else as a, in this case here as a Python function, very simple, which is to multiply two numbers. So now we check this part again. Now we say, okay, there are other cool models on the market. We don't want to use OpenAI. Maybe we want to use more coding. I personally, my favorite coding model is, I think, like many maybe from you also know, Sonnet 4.5. So we want now to use Anthropic. And remember the slides. So we check another implementation of it. And actually, all we changed was just this part. We just changed it to an Anthropic client. You see that in the C# implementation much better, even that it's really clearly abstracted. So Microsoft put a lot of effort to make a clear abstraction. So you really have to change just the client. And all the other things will work like before. The tool and all the other things will exactly work like before. And I think this is a cool thing. You could also do that with semantic kernel. But with semantic kernel, you had to change a little bit of things if you switch completely from OpenAI model to for example, to an Anthropic model. So this is one of the cool things. Now we go one further. I think, we could spend the whole day telling about how many different things there actually when it's coming to workflow. So there are much more high-level workflow things like sequential build-up, sequential agent, parallel agent, fan in, fan out. But we look a little bit in the basics that is below that workflows. Somebody asked here for share code. I will share everything later on GitHub. I will prepare it a little bit. Okay. Let's look here. What is behind of it when you build workflows? It's I told you already it uses graph, so I have to check the time to stay here on time. You can define edges and nodes, and we have here an uppercase as a very simple thing. It just makes things uppercase, and then we have another node that reverse texts, and we connect them together with the edge, and then we set which executor start first. Then we start the workflow, and let's see the basic thing here. Like we have here, you can have it just as a class or as a function, and it has a handler. So every of these executors can send messages, and to connect that edge, get these messages into the handler, but only if they match actually the input that you provide. So we send a text inside. This uppercase edge can receive this. Then we just make it upper, and then we send the message. And then every agent, every executor that is connected, like for example this one, get the text again. It has also the workflow context. Then it reverses the text, and in this case, it yields the output. That means kind of it's done its output for the end user. So this is a very, very simple example. You can there are special agent executors. So you can combine agents with just code steps with other steps. And yeah, the idea is that long term you have longer running enterprise businesses processes, and agents do some steps, but other steps may be built with classic code microservice, whatever. So there's a lot of things ongoing with agent chat, multi-agent, handoff agents, really a lot of different patterns for multi-agent. But now let's see what we can actually build with this. So for building the GraphRAG, let me make this a little smaller. There's a database, a public database. We can thousands of contract data. So I took 3 PDFs from there for the demo. I did it in 2 steps here. First, I use a large language model to extract the JSON. So I have it clearly the contracts in JSON. And yeah, this is really great that you can use large language models for this kind of extractions. And from this extraction, I built then my knowledge graph, which I store then to AuraDB. So that is the ingestion pipeline. And then on the other side, we have an agent or any kind of client, and it uses GraphRAG as a tool in this case. There would be another option in agent framework. You could also have context providers that you can also use for storing memories. But in this case, I use a tool for the implementation for the GraphRAG. It queries the AuraDB, and there's a nice helper that I hopefully have later on time to show you. Actually, Neo4j has a GraphRAG tool for Python, which already can take natural language queries and then convert it to Cypher queries, which I use in this project. But as I said, what I cannot show now, I will share later on. Maybe you follow me on LinkedIn or connect me there, so I will share it in the next few days there. So this is a contract. Yeah, it has 71 pages, just one of the examples, a network building and maintenance agreement. So we don't want to read that now. We rather want to extract it. So the extraction is also nothing to magic. Maybe we start here. Sorry, for main. We have a system prompt which tell, hey, we need that kind of data that we actually need for our graph. That's the extraction prompt. We create the extraction agent. I have input output here where I store then the JSON. Let's jump into the extraction agent part. And that's what we kind of learned before. I use, in this case, an Azure OpenAI response client, and then I create this agent. And the advantage of this architecture with the agent framework, I could also use the model directly here. But if I say, hey, I want to use Anthropic or Grok or whatever for the extraction, I just would, before, like you saw before, I just would have to change here the agent and everything would work like before. There's nothing too special about it. It's extract this as a JSON. I started already. Open the terminal. So it's extracting, and in the meantime, while it's here extracting the 3 contracts, we check one thing. It is, sorry, there's the agent, dev main, evaluate extraction. Here we go. Extraction prompt, agreement. So here is that part. So I defined a schema before. I read the PDF, and important is I use here then that Python schema to force the agent to bring out a clear JSON-based schema-based output with this agreement. So this is processing here. I think we can let it process a little bit while we check then already the next thing. The next part of the pipeline is then building the knowledge graph. So here I have all my Cypher queries. This is here it gets for sure the JSON data that I extracted in the previous step. We'll get into here's a parameter into the Cypher query. Then I create the nodes like agreement. I create the nodes like countries, the different parties, and set up all the connections. So there's also in the GraphRAG tool is also a basic knowledge graph builder, but it goes to the PDF like kind of chunking, and later on you have the agreements plenty of time. So I personally prefer to have here full control and to write here, build up my complete own knowledge graph and check that is really exactly what I want in the end. So this is all that Cypher thing. I also set it up a few full text indexes and so on. Let me see what else. Then I use again Azure OpenAI over Azure AI Foundry for creating the embedding. So this is my embedding generator, and here I actually generate the embeddings. So I think this is still processing. So I load the data from the contract, so it's also not too special. Maybe we wait till it. Oh no, it already finished one. So I think I stopped this now, so that I already generated them before, so that we don't need to wait now here till this is done. So one was already processed. There should be in where do I have it? Output. Data output. So yeah, they are here. We it's all extracted like I wanted in my schema. The LLM did a good job. Now let's go. Sorry, one thing too early. Sorry, a little too fast here. So let's run this. To build the graph. So now we see what's going on here. It creates the nodes and the relationship, the database indexes. And what takes a little bit longer is to generating the embedding. So for every excerpt, so for a part of that paragraphs, for every of these excerpts, I make a embedding so that I later on can find for certain queries like contract clause, competition clause, and things like this, that I can find them with a semantic similarity with a vector search. And so this takes the longest time here in the generation. Text, somebody is seeing this thing. Yeah, that's actually text to Cypher. That's the last part. I hope we will see it. That's exactly what I like most about that library is the text to Cypher. So this is done. So let's watch our graph. So let's execute that thing. Come on. So this is what we passed out of it. The contract. So we see here they have quite some relations. You have a marketing and affiliate agreement, and so we see we have even from the 3 documents we have already quite a graph. So let's move on. Half hour is quite tough. So now the next thing is we have a graph agent. That's the other side. So we have now everything ingested. We use LLM, embeddings, create a graph. And then that's all that stuff that we learned. We have here a nice agent instruction that he's a seasoned legal expert. So I have here then I have interactive mode and a demo mode in this. And this is actually all what we saw before. I have the response client, like in my very first getting started demo, just more tools. And because we are here a little bit short on time, I think we jump. These tools are not so special. To get contracts, I just have a tool. I get the contract ID, and then I do the cipher and bring back the JSON. The interesting thing is actually this is what the colleague asked for is this tool here. Let's jump there for the answer aggregation question. And you see, it is. Sorry, I did a little bit of abstraction. I have the tools and I have a service layer. So the tools are just a facade for the service layer. So we have to do one jump more. And this is now where we get natural language queries, what the user want to know, the user question, and then I use that tool, the text to cipher. You define a schema. There's unfortunately not a real officially kind of schema, but you describe it like this, so that the tool knows the schema of everything to build the right cipher query. And then you have here exactly what the colleague mentioned in the chat. You have the text to cipher retriever. And by the way, it also works with Azure OpenAI as a provider for this, so I can keep everything in my secure Azure AI Foundry bubble, but it works with other providers. And this is then the schema that I just here, that needs it also as a parameter that it knows what it built. And then I just give it to the retriever. Let's say it is also not a rocket science to build it yourself. It uses internal. You have to provide them a large language model. You give them the schema. You give them the query. The large language model creates the cipher out of it. But you see, it's really just a few lines that you can use very, very easy in kind of every tool. Then let me see if we finally can start my agent. There is Microsoft provides also. I have to open the toolbar. Still here, the cipher. A dev UI for the agent framework. So you can just, that agent that you saw before, it will automatically read this, so you don't have to do many things here. And it will just start that agent. I think I have here a resolution problem. So one last query, I think then we're out of time. Yeah, luckily they are not so sensitive with typos, the models. And you see here also all the tools calls that will going on in the background. Let me check a second how we are here in time. So you see here already some tools calls ongoing. So you can monitor all of this. You see all the events that the engine fires in the background for troubleshooting. I didn't configure the OpenTelemetry provider, so it doesn't work. And you see already here that tool call brought me some results. You can easily troubleshoot this, what is actually going on in the background. So I think we 1 minute left here. So I think we call it a day for today. I will prepare that example a little bit, and I think, let's say, not later than next week or weekend, I will publish that on GitHub, so you can easily use it as a template. So thank you for watching and listening.